to the magical time when we added fractions. So if I said like 5/6 plus 3/10, how do we add those together without a calculator? Common denominator. So like what do 6 and 10 both go into? 30. Well,
Did you just say 12?
um, a lot of times when I ask that question, I'll get the answer 2. No. 6 and 10 go into, 2 goes into them, but 6 and 10 go into 30. So how do I turn it into a 30? Times 5, times 5, times 3, times 3, right? So anything you multiply the bottom by to keep the fraction equal, you gotta multiply the top by the same thing. Keeps the fraction the same value. And then you just do top times top. And then on the bottom, what? It doesn't change, right? Or whoops. On the bottom, it doesn't change, right? You just keep the same denominator. So yeah, and in this case, this part doesn't apply as much today, but you could reduce by dividing by 2 here. Okay, you guys remember that? And subtracting, same thing. Same rules with subtracting. Yeah. So, the first part, like if I just said two random numbers like, I don't know, 7 and 9, what do 7 and 9 both go into? 7 times 9, right? So sometimes numbers have something in common, like 6 and 10 both have a 2, so you don't just multiply 6 times 10, but a lot of times what they both go into is just whatever they are multiplied together. 7 and 9 both go into 7 times 9, 63, right? That's usually how it works. Unless they have something in common. Okay, so if it's like, I use A's here. Okay, we're doing polynomial, so it's going to look more like this. Let's do, okay. What do these both go into? Well, for like the A, well, all these things really, you're gonna, maybe I should have thrown a number in there. There. Okay, what is the common denominator, well, the common multiple? These aren't denominators right now, but what can these both multiply into? So the 5 and 2 both go into what? 10. Okay, what do A3 and A both go into? Okay, A3. So basically you just use the most. The smallest thing A cubed can go into is A cubed. Okay, A can also go into A cubed if you multiply this by A squared, right? So whichever letter has the most exponent, that's what you use. And so on the B's, B cubed. On the A minus 3's, squared. Okay, that's the common multiple, like a common denominator. This is a lot messier than the normal problems, but you guys get kind of how it works? Okay, good. Lovely, beautiful. Page 395, we're in number 1.
Played like 15 minutes of young pong and walked out of the cafeteria drenched in sweat.
He was really sweaty coming in today.
I'm not surprised.
From ping pong?
You
Yes.
I'm not surprised.
Full contact ping pong. Maybe he was doing something besides ping pong, like chasing people around. Okay. Huh? All right. Least common multiple. What do 3 and 15 both go into? 15. 3 times 5 is 15. 15 times 1 is 15. How about the x's? How many x's am I going to use? 1. Because this one has 1, so we need at least 1. How many y's am I going to use?
2.
Y squared and z's?
1.
1z. 1z. Too bad Will's not here.
He's gonna watch this video and be like, that was enjoyable.
What was it?
I said 1z, and then I said 1z. You're not, get on Will's level, people. You have to always be on your toes.
He's like on his heels when he walks.
Okay. Do either of these things, that wouldn't be literal. Do either of these things factor? No. So what's the common denominator? Okay, these are just two independent things. So the thing that they'll both go into is whatever that times that is. We're not going to multiply it together though. We're just going to show them multiply together.
Oh. Okay.
We're not to the hard part yet. The common denominator for whatever b minus 4 is, 4b minus 1 is, they don't have anything in common. So whatever, it's kind of like 8 and 7. What's the common multiple of 8 and 7? 56. 8 times 7. The common multiple of this is whatever that times that is.
So do the same thing on 2 or not?
2. No, you need a factor on 2. So 2 is more like number 5. Number 5, x minus 2 squared. So just remember, x minus 2 squared, that just means x minus 2 times x minus 2, right? We got 2 of those. And then x squared plus 5x minus 14. If it looks like it can factor, you need to factor it. That's kind of the rule here. So what does this factor to? What multiplies into negative 14? That would add up to 5.
7 minus.
Okay, that's not the answer. That's just, we need to break it down to the factors because we use the factors to make the common multiple. So how many x minus 2's, maybe I should put it back. How many x minus 2's should I use?
1.
2. Remember, you got to use the most of each. So, no. Okay, this goes into x minus 2 squared because it's just this times 1. This goes into x minus 2 squared because it's just this times x minus 2. You don't need 3 of them, you just need something they both go into. They both go into x minus 2 squared. How many x plus 7's do I need to use? 1. So that's the common multiple. Does that make sense? So I didn't use 3. We didn't say these 2 pluses. I just used whoever had the most, basically. This one had the most x minus 2's, so I used 2. This one had the most x plus 7's, 1. So I just used 1. Number 7. Alright, time to start the party. 7 over 5y. This one's actually easy.
Yeah, we have a common.
They already have a common denominator, 6 over 5y. So because they already have a common denominator, we just need to add the numerators. 7 plus 6 is, no, 13. Incorrect.
We're now at 8.
Okay, now at the end you should say, does this reduce? Does 13 over 5 reduce? No. So that's the it. That's it. That's the it.
Just need 20 more.
How do you spell that? That should be your senior too.
Spell what now?
The hiccup thing.
So,
How do you spell a hiccup?
Like, how would you spell that? How would
Like-
you spell the noise?
Just put
They're like an onomatopoeia.
Just put belch.
They don't have one
Uh,
for hiccups. They just usually like put a hiccup with the little like asterisks in there. X squared over 3 minus.
Would you have to?
Okay. Yeah. So if you have a negative in this fraction, it's kind of like the whole fraction is negative. So what are we actually doing here? Adding. So it's really like x squared over 3 plus 2/3.
Oh.
You guys follow that? If there's a negative in here, it's like the whole thing is negative. So minus negative makes it actually like a plus. So x squared plus 2, does that simplify? No, that means multiply. It's just x squared plus 2 over 3. Okay, this is where we're starting. We're starting to ramp it up here. 5a over a plus b. Alright, so they do not have a common denominator. I need to figure out what the common denominator is going to be. So what do this and this go into? A times, remember you gotta use whoever has the most. So we need an A and we need an A plus B. Common denominator is A times A plus B. Alright, so how do I turn this into the common denominator? What's it missing? Times A, right? I can put it on the front, I guess it doesn't really matter. But so if I multiply the denominator by A, I need to multiply the numerator by A. So it'll be 5A squared. On this one, what's this denominator missing?
A plus B.
A plus B. So if I multiply the denominator by A plus B, I need to multiply the numerator by A plus B. Okay, we're really done with the denominators. There's not, you don't really do stuff with the denominators on adding and subtracting. You kind of use it to set up the numerators, but I already know that my denominator is going to be this right here. Okay, these are the same thing as this. They're done. It's really the numerators where we're doing stuff. So what we're doing is 5a times a, 5a squared, minus 6a plus b. And we just need to simplify that. We could have written it up here, but so negative 6 is like distributive property. So it's 5a minus 6a.
Isn't it 5a squared?
Oh, sorry. Minus 6b. And does that simplify any more? Can we do anything with that? No. I don't know if I want to write my answer like that. I'll just put it over here, I guess. 5a squared minus 6a minus 6b over a plus b. One small note here. If the top would have factored, we probably should factor to make sure it doesn't reduce with the bottom. This doesn't factor. It is 3 terms, but it's not in the right pattern. It doesn't say a squared a number, or it doesn't say a squared ab b squared. Those are the patterns. This doesn't factor. So we're done. I think we're just gonna go to 16 today. Like I said, I recognize this is a challenging lesson. Okay. On 13, are those two denominators the same thing? No. But they actually are related. We talked about this a couple days ago. Like, remember when we were reducing these? Do they reduce? Yeah, they're opposites. So they reduce to -1. They're not the same thing, but they are opposites. So what that means is, if I take like a negative out of 5 minus m, what I would be left with is -5 plus m, which is the same thing as m minus 5. So they're not exactly the same, but if I take a negative out of one of them, like divide by -1 kind of a thing, they actually do become the same. So where do I put the negative? Well, just like in front. So I could rewrite this as plus -2 over m minus 5. Does that make sense? Okay, they're not the same, but if you take a negative out of one of them, they do become the same. So instead of 5 plus 2 on top, it's really like 5 plus -2, or 5 minus 2. So it's just 3 over m minus 5. Now on 15, t plus 6, 6 plus t, are those the same?
Yes.
Yeah. Order of addition makes no difference whatsoever. So 15 is actually one of the easiest ones because they are common denominators. So it's just 3t over t plus 6 minus 4t over t plus 6. So 3t minus 4t is negative t. Or you could put the negative out in front. I don't know, what did the book do? They put it in front. Doesn't matter though. There's a negative, it's just negative. Does that reduce?
T's.
No. I knew I was going to be able to tempt somebody. There you go, answer. Yes, I did. Does not reduce. I would have counted this one also, that's the same thing.